Greetings, my dear listeners. Today we begin a long journey into the realm of ideas, hypotheses, and daring speculations. Our theme is the multiverse. The very word sounds as if it belongs to the pages of a science fiction novel, yet today it finds its place in lectures of physicists, in scientific articles, and in philosophical debates. It captivates writers and artists, and it invites millions of people to look at reality in a completely new way. What if our world is not the only one? What if the universe itself is just a single petal of a vast cosmic flower, where countless other petals blossom beside it? This thought has been with humanity since the dawn of history. In myths and legends, people always imagined worlds beyond the visible. The Sumerians spoke of heavenly spheres where gods dwelled. The Mayans believed in 13 heavens and 9 underworlds. The Norse imagined 9 worlds tied together by the cosmic tree Yggdrasil. In all of these visions, the world was not singular. Humanity has always sought to reach beyond the horizon and imagine other realms. Philosophy gave birth to some of the earliest ideas of multiple worlds. Leucippus and Democritus, founders of the atomist view of nature, argued that everything consists of atoms and void. If there are infinitely many atoms, then there must also be infinitely many worlds. Epicurus expanded this, suggesting that some worlds are like ours, while others are entirely different, without life or governed by laws unlike our own. For the Greeks, this was not an experiment but a logical consequence of infinity. The Middle Ages told another story. In Europe, Christian cosmology dominated. The world was unique, created by God, with Earth at its center. The idea of other worlds was considered heresy. Yet even then, there were bold thinkers. Nicholas of Cusa spoke of an infinite universe, where Earth was not the center, but only one among many points. Later, Giordano Bruno went further, declaring that the cosmos contained countless suns and worlds, some perhaps inhabited. His daring words cost him his life, but they set. In the age of science, everything began to change. Galileo lifted a telescope to the sky and saw mountains and craters on the moon. The heavens were no longer perfect spheres of light. They were material, flawed, like Earth itself. Kepler, Newton, and later astronomers expanded this vision. Suddenly, the thought of other worlds no longer seemed like myth. It became a scientific possibility. If planets revolve around stars, why not imagine countless worlds beyond our own? By the 19th century, the idea had moved into literature. The French astronomer and writer Camille Flammarion filled his books with both astronomical facts and imaginative visions of life on distant planets. Writers such as H.G. Wells used the possibility of other realities as a way to explore society, morality, and the human condition. Science fiction gave us portals into parallel universes long before physics had the courage to consider them. Today, in the 21st century, the idea of the multiverse is discussed at physics conferences. It appears in the works of Stephen Hawking, André Linde, and Michio Kaku. Inflationary cosmology suggests that the birth of many universes might be natural. Quantum mechanics adds its own strange twist, hinting at parallel realities. We still lack direct proof, but the very language of science now makes room for this mystery. Why does the multiverse captivate us so deeply? Perhaps because it holds up a mirror to our existence. If there are countless worlds, then ours is just one among many. We are not the center, not the exception. And yet there is comfort in this thought. Maybe elsewhere, another version of us made a different choice. Maybe somewhere, the universe is so hostile that life never arose at all. This thought unsettles and inspires us in equal measure. Let us ask a rhetorical question. If infinite worlds exist, does that make ours less significant? Or does it make it infinitely more precious? Out of billions of stars, we search for another Earth. Out of endless possible universes, this one became our home. It gave rise to life, consciousness, and the ability to reflect upon the cosmos itself. Is that not a miracle? Philosophers say, humanity always seeks the boundary so that it may cross it. We discovered continents, climbed mountains, and reached for space. Now we strive to learn if the universe itself has a limit, and if it does, what lies beyond it? The multiverse is not only a hypothesis of physics, it is a symbol of our eternal longing to step beyond the possible. The stories of those who thought of many worlds are dramatic. Giordano Bruno perished, but his ideas survived. Edgar Allan Poe, in his essay Eureka, anticipated many ideas of cosmology. Andre Linde, one of the architects of eternal inflation, recalled that his early ideas were dismissed as fringe science, yet today they provide one of the most serious frameworks for discussing the multiverse. The truth is born through doubt, through debate, and through courage. This first part of our journey has only opened the door. In the chapters ahead, we will explore the different versions of the multiverse, from inflationary cosmology to quantum mechanics, from the anthropic principle to string theory. We will examine both scientific arguments and philosophical reflections, myths and art, and the lives of those who dared to dream. So, my dear listeners, we embark on this path together. We will walk the line where science meets imagination, where myths become the seeds of discovery. We will ask questions that may never have final answers, but therein lies the power of science and philosophy, to seek and to wonder without fear. Let our journey into the multiverse begin right now. In the previous part, we turned to myths and early philosophical reflections on the multiplicity of worlds. Now it is time to step into the realm of science and trace how the idea of many worlds began to emerge from astronomy and physics. This is not the invention of poets, but the result of centuries of observation, bold speculation, and revolutionary discoveries. It all began with a shift in perspective in the 16th century. For centuries, Europe lived under the geocentric worldview. Earth at the center, the heavens revolving around it. But Nicholas Copernicus proposed a heliocentric system, with Earth and the planets orbiting the sun. This was not only a scientific breakthrough, but a philosophical earthquake. If Earth is not the center, perhaps the universe itself is not unique. Perhaps there are other worlds beyond. Galilei confirmed Copernicus with his telescope. He discovered mountains and craters on the moon, moons orbiting Jupiter, and the phases of Venus. These findings shattered the notion of perfect heavenly spheres. The moon and planets were revealed as worlds of their own, material and flawed like Earth. Could they not also be homes for life? Already the seeds of multiplicity were planted in the soil of science. Johannes Kepler took this further. In his imaginative work, Somnium, He described a journey to the moon and speculated about its inhabitants. To him, it seemed only logical. If Earth is but one planet among many, why should life be confined here? Isaac Newton then unified the heavens and earth with his law of gravitation. The same force that pulls an apple down also keeps the moon in orbit. One set of laws governs the whole cosmos. If so, why not imagine countless worlds governed by these same principles? In the 18th century, philosophers and scientists began to embrace the plurality of worlds. The French thinker Bernard Le Bovier de Fontenelle wrote Conversations on the Plurality of Worlds, a charming popular science book that introduced laypeople to the idea that stars are suns, each possibly with their own planets. This was the first time the notion of other worlds was explained in a way accessible to everyone, and it was embraced with enthusiasm. The idea spread beyond academia, fueling both curiosity and the 19th century brought new tools and evidence. With the advent of spectroscopy, scientists could analyze the light of stars and discovered that they were composed of the same elements as Earth. Suddenly, the heavens and earth were united not just by mathematics, but by chemistry. The stars were not divine fires, but distant suns, familiar in substance. The possibility of life beyond Earth gained scientific plausibility. Camille Flammarion, the French astronomer, merged science and imagination in his writings. He suggested that nature was too generous to create only one world fit for life. He believed that countless planets must be inhabited, and though many of his claims were more poetic than empirical, they captured the imagination of readers worldwide. Science fiction and scientific speculation were feeding each other, blurring the line between possibility and dream. Then, in the 20th century, came a true revolution. Edwin Hubble, studying distant galaxies, discovered that the universe was far larger than anyone had imagined. The Milky Way was not the whole cosmos, but just one galaxy among billions. The scale of existence expanded overnight. If there are so many galaxies, each with billions of stars, then how many worlds might there be? This discovery alone transformed the conversation about multiplicity from fantasy into something close to inevitability. At the same time, physics itself was undergoing upheaval. Quantum mechanics revealed a world of probabilities, where events unfold in multiple possible ways. Some physicists began to wonder, could all these possibilities actually exist, realized in different branches of reality? The seeds of the many worlds interpretation were planted, though they would not fully blossom until later. Still, the idea that our reality is not the only one gained more and more traction. Philosophically, the plurality of worlds raised questions that went beyond science. If the cosmos contains innumerable worlds, what is the place of humanity? Are we unique or ordinary? If Earth is one planet among countless billions, are we still special? The answers varied, but the questions themselves reshaped the human self-image. For many, the loss of uniqueness was not a diminishment but a liberation. We are part of a vast, living universe, not the center of a small one. The stories of scientists reveal the courage it took to expand horizons. Giordano Bruno was executed for daring to speak of countless worlds. Galileo faced the Inquisition for insisting on the reality of Jupiter's moons. Hubble changed everything by showing that the Milky Way was not the whole. These figures risked ridicule, persecution, or worse, all in the pursuit of a larger truth. the cosmos is bigger than we can imagine. Here lies a rhetorical question. What does it mean for us to know that there are innumerable worlds? Does it diminish our significance, or does it grant us new dignity as part of something greater? Perhaps it does both. Our lives are tiny in the grand scale, yet the very fact that we can grasp this scale makes us extraordinary. We are fragile, but we are also aware, and that awareness is itself a marvel. Thus, the scientific origins of the idea of many worlds are the story of bold steps and revolutionary visions. From Copernicus to Hubble, from Fontenelle to Flammarion, from Newton to the pioneers of quantum mechanics, each contributed to a widening horizon. Science showed us that the universe is vaster than anyone dreamed. And in the next part, we will see how modern cosmology, particularly the theory of inflation, took this even further, making the multiverse not just a possibility, but a natural consequence. Modern cosmology has opened before us horizons wider than any philosopher of the past could have imagined. Among its boldest ideas is inflation, the concept that in the earliest fractions of a second after the Big Bang, the universe expanded at an unimaginably rapid rate. This theory, born in the late 20th century, not only explained puzzles about our cosmos, but also paved the way for one of the most daring notions of all, the eternal birth of universes, the multiverse itself. Let us begin with the problem inflation was designed to solve. When astronomers look at the universe on the largest scales, they see that it is astonishingly uniform. Galaxies are spread evenly in every direction, and the cosmic microwave background, the faint afterglow of the Big Bang, is nearly identical no matter where we look. But why should this be? In the standard Big Bang model, distant regions of the universe should never have been in contact with one another. How could they end up so similar? Inflation provided the answer. Alan Guth, a young physicist in 1980, proposed that in its earliest instant, the universe underwent a phase of exponential expansion. In less than a trillionth of a second, space stretched by a factor so enormous that regions once in close contact were blown apart to cosmic distances. This rapid expansion smoothed out irregularities, explaining the observed uniformity. It also accounted for other mysteries, such as why the geometry of the universe appears flat, and why certain But here is where things become even more extraordinary. Andrei Linde, a Russian physicist working in the United States, refined Guth's idea into what became known as chaotic inflation, and later, eternal inflation. According to Linde, inflation does not stop everywhere at once. In some regions, it comes to an end, allowing universes like ours to form. In others, it continues indefinitely, spawning new bubbles of reality. Each bubble becomes a universe in its own right, with its own laws of physics. This image is breathtaking. A vast inflating space, endlessly producing bubble universes, each potentially different from the others. Some may have the same constants and particles as ours. Others might be radically alien. Gravity may be stronger or weaker. Chemistry may be impossible. Time itself may behave differently. The multiverse, in this vision, is not just speculation but the natural consequence of inflationary dynamics. Linde himself has spoken about how stunned he was by this conclusion. He recalled that when his equations first led him to the idea of eternal inflation, he could hardly believe it, yet the mathematics pointed there relentlessly. "I did not want to believe it," he said, "but the equations insisted." For decades, his ideas were met with skepticism, but gradually, eternal inflation has become a serious framework considered by cosmologists worldwide. Do we have evidence for inflation? Indirectly, yes. The cosmic microwave background carries faint ripples, tiny fluctuations in temperature, that match predictions of inflationary theory. These ripples later grew into galaxies and clusters of galaxies. The discovery of this pattern was a triumph for inflation. As for eternal inflation, the evidence is less clear. Some scientists suggest that anomalies in the cosmic microwave background might be the signatures of collisions with other universes. Philosophically, eternal inflation changes everything. In the traditional picture, the universe had one beginning, one story. With eternal inflation, there is no single creation moment. Universes are born continuously, endlessly, in an eternal process. The metaphor of a single Big Bang is replaced by a cosmic symphony of countless bangs, each giving birth to a new world. Beginning and end lose their absoluteness. What remains is perpetual creation. Rhetorical questions arise. If we are but one bubble among infinitely many, what is the meaning of our existence? Does our universe matter less, knowing there may be countless others? Or does it matter more, precisely because this is the universe that gave rise to us, to consciousness, to the very ability to ask these questions? Perhaps uniqueness lies not in being the only universe, but in being the one we inhabit and experience. The story of eternal inflation is also a story about the courage of scientists. Alan Guth's initial idea was so bold that many dismissed it. Lindy's refinements were considered speculative for years, yet science advances through such daring leaps. Today, their ideas form part of mainstream cosmology, and textbooks discuss inflation as the standard explanation for the early universe. What once seemed fantastical is now a cornerstone of our understanding. Let us pause to reflect. Imagine a vast sea of space, bubbling eternally with new worlds. Somewhere, even as we speak, a universe is being born. Its laws may be strange, its future unimaginable, and yet it exists, part of the same reality that produced us. In contemplating this, we glimpse the immensity of creation, and perhaps, in that immensity, we also find a mirror of our own desire to reach beyond the limits of the known. Thus, inflationary cosmology does more than explain the smoothness of the sky. It opens the door to infinity. It suggests that our universe is not the only one, but one bubble in an eternal froth. And in the next part of our journey, we will turn to quantum mechanics and its peculiar implications. For there, too, we will find hints of a multiverse, born not of cosmic expansion but of the strange and subtle logic of probability itself. Quantum mechanics not only gave science new equations, it gave us new paradoxes. It revealed that the world is built on principles that defy everyday logic. At the heart of quantum theory lies the principle of superposition. A particle can exist in multiple states at once until an observation is made. This strange feature became the foundation for one of the boldest ideas in the history of physics, the many worlds interpretation. In 1957, a young physicist named Hugh Everett put forward a radical proposal. He suggested that when a quantum measurement occurs, the universe does not collapse into a single outcome. Instead, it splits. In one branch, the particle behaves this way. In another, it behaves differently. Each possibility is realized in its own world. Thus, every quantum event creates multiple universes, branching endlessly. Philosophically, this is astonishing. If Everett is right, then every decision we make also creates new realities. In one universe, you take the job. In another, you decline. In one universe, you turn left. In another, you turn right. All possible outcomes are real, just not accessible to us. This is not science fiction, but a serious interpretation of quantum mechanics still debated by physicists today. Of course, critics abound. The many worlds interpretation seems extravagant, offering an unthinkable number of universes. It also resists direct verification, yet it arises naturally from the mathematics of quantum theory. Everett argued that there is no need for a mysterious collapse of the wave function. Instead, we should accept that all possibilities exist. This view removes paradoxes but demands that we accept a reality stranger than anything imagined. Everett's own story is poignant. His work was largely ignored during his lifetime. Disillusioned, he left academia and applied his talents elsewhere. Decades later, physicists began to revisit his ideas. Today, Everett is recognized as a visionary, his name spoken alongside the giants of modern physics. His fate reminds us that truth is not always accepted immediately. Let us pause for a rhetorical question. If all possible choices are realized somewhere, what does that mean for free will and responsibility? Does it cheapen our decisions? Or does it make them even more meaningful, since the branch we experience is uniquely ours? Perhaps the value of choice lies not in its exclusivity, but in the conscious act of living through one path while knowing others may exist beyond our reach. Quantum mechanics adds further puzzles. Entanglement reveals that particles can remain connected across vast distances, influencing each other instantly. This spooky action at a distance, as Einstein called it, suggests that our universe may be linked in ways we barely understand. Some thinkers even wonder whether entanglement is a glimpse of a deeper, multi-layered reality. Could it be that what we call our universe is but a shadow of a richer, higher dimensional structure? Philosophers have long debated the implications. If all outcomes are real, then uniqueness is not a property of reality, but of experience. Our life becomes an act of attention to one branch among countless others. Consciousness, in this view, is not about collapsing possibilities, but about inhabiting one. This transforms existence into a dialogue between infinity and the self. Modern physicists like Max Tegmark have expanded these ideas, categorizing different levels of multiverse. The quantum level, the many worlds interpretation, is only the beginning. Tegmark argues that mathematical structures themselves may constitute realities, and that our universe is simply one among them. Everett's vision thus becomes part of a grander map of possibility. The many worlds interpretation also inspired art and literature. Writers have crafted stories of parallel selves meeting, of choices replayed across universes. Films explore the emotional and existential weight of branching realities. Through these tales, we confront the same philosophical questions as science. What defines identity, meaning, and purpose in an infinite sea of possibilities. Critics remain skeptical, pointing out the lack of testable predictions, yet supporters reply, the absence of collapse is itself the simplest explanation. To invent mysterious mechanisms to avoid many worlds may be the greater extravagance. In physics, simplicity often guides us, even when it leads to unsettling conclusions. So what does this mean for us? If every decision creates new branches, then our lives are woven into a cosmic tapestry of infinite patterns. We cannot experience them all. We live only this one, and therein lies its value. In the face of infinity, this moment is precious. Thus, quantum theory is not only a tool for calculation, but a source of philosophical upheaval. It compels us to reconsider what reality is and what it means to choose. In the next part, we will turn to the anthropic principle, the idea that the very fact of our existence as observers shapes how we understand the universe, and perhaps even why our universe allows life at all. The anthropic principle is one of the most fascinating ideas in modern cosmology, directly connected to the multiverse hypothesis. At first glance, it sounds simple. The universe must be such as to allow the existence of observers. But behind this apparent banality lies a profound philosophical and scientific meaning. Scientists have long noticed that the laws of nature seem finely tuned for the existence of life. A slight change in fundamental constants would render the universe sterile. If gravity were stronger, stars would collapse into black holes too quickly. If it were weaker, they would never ignite. If the electron's mass were even slightly different, atoms could not form stable molecules. Even the cosmological constant, which governs the expansion of the universe, seems exquisitely balanced. Too large, and galaxies would... Why, then, are the parameters of the universe just right for life? Here the anthropic principle offers an explanation. In its weak form, it says, "We observe the universe to be this way because only such a universe allows observers to exist." In its strong form, it ventures further. The universe must, by its very nature, give rise to life. The connection to the multiverse is clear. If countless universes exist, each with different laws, it is no surprise that we find ourselves in one compatible with life. Ours is not a miracle of fine-tuning, but a consequence of selection. Most universes may be barren, but at least one, ours, produced consciousness. Philosophically, the anthropic principle is polarizing. Some dismiss it as a tautology. Of course, we find ourselves in a universe that permits us to exist. Others see in it a key to understanding our place in the cosmos. For if the odds of life-friendly conditions are astronomically small, then the very fact of our existence feels miraculous. The multiverse transforms this miracle into inevitability. The history of the principle itself is revealing. It was first clearly formulated by physicist Brandon Carter in the 1970s. His proposal sparked debate. Some called it philosophy, not science. Others saw it as a necessary recognition of the observer's role. Later, physicists John Barrow and Frank Tipler expanded it into a sweeping framework in their book, The Anthropic Cosmological Principle. The book stirred controversy, yet it cemented the idea as part of the scientific conversation. Consider the cosmological constant again. If its value were only slightly higher, galaxies could never form. If slightly lower, the universe would collapse too soon. Why is it just right? The anthropic principle responds, because only with such a value could we exist to ask the question. Other universes may have different constants, but they contain no observers. We find ourselves in the rare universe where conditions allow life. Rhetorical questions naturally follow. Does the anthropic principle make us more significant, or does it underscore our randomness? Are we special, or are we just one coincidence among countless possibilities? Perhaps both. We may be accidental in the vastness of the multiverse, yet unique in the story of our own experience. Our lives may be improbable, but they are also irreplaceable. The principle has influenced not only science, but also culture. Science fiction often plays with the idea of fine-tuned universes, imagining alternate realities where a tiny shift in constants erases life altogether. These stories echo the same truth. Our existence rests on a razor's edge, and it is precisely this fragility that makes it meaningful. Some physicists use the anthropic principle pragmatically. For example, it has been invoked to explain why certain constants, like the cosmological constant, have the values they do. Instead of searching for a deeper law, the anthropic principle suggests that in a multiverse, values simply vary, and we live in the rare case compatible with life. Critics object that this is an excuse to stop searching, but others argue that it is a natural extension of our understanding. Let us reflect. Does the anthropic principle offer answers, or merely more questions? Perhaps its greatest value lies in opening our minds. It reminds us that we are not detached observers, but part of the universe itself. Our very ability to ask questions is entwined with the structure of reality. Science and philosophy meet here, as we ponder not only how the cosmos works, but why it permits beings like us to exist. Thus, the anthropic principle bridges physics and philosophy. It suggests that the mystery of our existence is inseparable from the laws of nature. It connects the idea of the multiverse with the miracle of life, turning improbability into possibility. In the next part, we will turn to even bolder hypotheses, string theory and extra dimensions, which also open doors to a universe of many worlds. String theory is one of the most ambitious attempts in modern physics to unite all the forces of nature into a single framework. Born in the second half of the 20th century, it captivated scientists and the public alike with its almost poetic imagery. At its heart lies a simple but revolutionary idea. The fundamental building blocks of the universe are not point-like particles, but tiny vibrating strings. The way these strings vibrate determines everything in existence. In this view, every particle, electron, quark, photon, is simply a particular vibration mode of the same underlying string. Just as a violin string can play many notes depending on how it vibrates, the cosmic string can produce many particles. This metaphor of a cosmic symphony captured the imagination of physicists and laypeople alike. The universe becomes music, its laws the melodies of strings vibrating in harmony. But there is a catch. For string theory to work mathematically, the universe must have more dimensions than we perceive. Our everyday experience is limited to 3 dimensions of space and 1 of time. Yet string theory requires 10 or even 11 dimensions. Where are they? Physicists suggest that the extra dimensions are curled up into minuscule shapes, far too small for us to detect directly. We live on a 3-dimensional brain, while beyond it lies a hidden higher dimensional structure. This realization opened the door to a striking idea. If the extra dimensions can fold in many different ways, then each configuration may correspond to a different universe with its own laws. The equations of string theory allow for a vast landscape of possible worlds, so many that the number is almost inconceivable. Some universes may be sterile, unable to support even stable atoms. Others may host physics utterly alien to us. Our own universe, in this view, is but one patch in this enormous landscape. Here, string theory and the multiverse intertwine. Why is our universe fine-tuned for life? Because in the landscape of string theory, only certain configurations allow complexity. We happen to inhabit one of them. Other universes may exist with different parameters, but they are barren. Life emerges only where the geometry of hidden dimensions permits it. The history of string theory is dramatic. In the 1980s, it experienced a great surge of interest. Physicists were exhilarated by its elegance and unifying power. But disappointment followed when it failed to produce concrete, testable predictions. Critics accused it of drifting into philosophy rather than physics. Yet supporters argued that it offered the most comprehensive framework yet for unifying gravity with quantum mechanics. Even if incomplete, it gave language to possibilities that no other theory. In the 1990s, the picture grew even richer with the rise of M-theory, which united different string theories into a broader vision. It suggested that the universe might not only consist of strings, but also higher dimensional membranes, or brains. In this picture, our entire cosmos could be a three-dimensional brain floating in a higher dimensional space. Parallel brains might exist nearby, invisible but real, each one a universe of its own. Some theorists even propose that collisions between brains could. This vision is breathtaking. Imagine universes as pages in a vast book, stacked side by side, separated by only a sliver of extra dimension. Our page is all we know, but countless others may exist just a breath away, unreachable, yet real. Such imagery captures not only the scientific, but also the poetic spirit of string theory. Rhetorical questions naturally arise. If parallel brains exist, could we ever detect them? Could gravity leak into higher dimensions, offering a clue? Could cosmic events like the Big Bang be the result of brains colliding? These are not fantasies, but serious questions explored in theoretical physics. Experiments have not yet given answers, but the very act of asking stretches our imagination. String theory also inspires philosophy and art. The metaphor of hidden dimensions resonates with the human sense that reality has depths beyond what we see. Writers and artists portray universes layered upon universes, realities stacked like Russian dolls. The scientific theory becomes a metaphor for human existence. Visible life is only the surface of something vaster. Critics continue to challenge string theory for its lack of testability. But history reminds us that many ideas once thought untestable eventually found evidence. Atoms, black holes, gravitational waves, all were once dismissed as speculative. Perhaps the same fate awaits string theory. Or perhaps its true role is to expand our thinking, to show us that reality may be richer than our current tools can grasp. So what does string theory mean for the multiverse? It suggests that countless worlds may exist, each defined by the hidden geometry of dimensions. We find ourselves in one where life is possible, not because it is the only one, but because in others life cannot arise. Far from diminishing us, this vision magnifies the wonder of our existence. Out of a vast landscape of possibilities, here we are. Thus, string theory and extra dimensions open before us a cosmic panorama. We live in 3 dimensions, but beyond lie hidden spaces shaping everything we know. Perhaps someday experiments will reveal their traces. Perhaps they will remain forever beyond reach. Either way, the idea itself changes us. It reminds us that reality is not flat and simple, but layered, musical, and infinite. In the next chapter, we will turn to the mysterious dark energy and the cosmological constant, which also hint at the possibility. Dark energy is one of the greatest mysteries of modern physics. We know almost nothing about its true nature, and yet it dominates the fate of our universe. And perhaps it also points toward the possibility of a multiverse. The story begins in 1917, when Albert Einstein introduced the cosmological constant into his equations of general relativity. At the time, scientists believed the universe was static and eternal, and the constant was a mathematical trick to hold it in balance. But only a few years later, Edwin Hubble discovered that the universe was expanding. Einstein reportedly called the cosmological constant his greatest blunder. For decades, it was largely forgotten. Then came a revolution. In the late 1990s, 2 teams of astronomers studying distant supernovae made a shocking discovery. The expansion of the universe is not slowing down, as expected, but accelerating. Something unseen was driving galaxies apart at an ever faster pace. Scientists called it dark energy, a mysterious force that seems to make up nearly 70% of the universe. Here lies the puzzle. The value of the cosmological constant, or whatever dark energy may be, appears to be finely tuned. If it were only slightly larger, galaxies would never have formed. If smaller, the universe would have collapsed long ago. Why is it just right for life? The anthropic principle offers one answer. We live in a universe with the right value because only such a universe allows observers. In a multiverse, most universes may have the wrong values. Ours is one of the rare exceptions. Philosophically, this is both humbling and inspiring. If other universes exist where dark energy prevents stars and planets, then our universe is not unique. It is one among many. Yet precisely because it allows life, it is extraordinary to us. Out of countless sterile realities, this one blossomed with galaxies, stars, and minds capable of wonder. Scientists debate what dark energy really is. Some think it is an inherent property of space itself. Others suggest it arises from an unknown field or interaction. Some speculate it could be a sign of hidden dimensions or the influence of neighboring universes. None of these ideas are proven, but all of them expand the imagination and push the boundaries of science. The stories of discovery are dramatic. When the acceleration of the universe was first observed, many astronomers could hardly believe it. It overturned centuries of assumptions about cosmic gravity. The scientists who made the discovery were awarded the Nobel Prize, but they admitted that the result was unsettling. The cosmos was not only stranger than we thought, it was stranger than we could have imagined. Let us pause with a rhetorical question. If the nature of dark energy remains unknown, does that mean we will never understand it? Or is it the next great frontier of science, waiting for the right instruments and insights. Perhaps the mystery of dark energy is itself a clue that our universe is part of something larger. If its value is determined not by a fundamental law, but by selection among many universes, then the multiverse becomes more than speculation. It becomes a natural explanation. Philosophers see in dark energy a symbol of human vulnerability. Our existence depends on an equilibrium so delicate that even the slightest shift would erase us. And yet, they also see hope. If universes are countless, then life is inevitable somewhere. We are fragile, but we are not alone in possibility. Dark energy also inspires cultural imagination. Writers and filmmakers portray universes tearing apart under its relentless push, or civilizations seeking to harness it. These stories echo the same tension scientists feel: awe at its power, fear at its mystery, and wonder at the fact that we exist in spite of it. Thus, dark energy and the cosmological constant are not just scientific curiosities. They are gateways to profound philosophical reflection. They remind us that the universe is more finely balanced than we can fathom, and they open the door to the multiverse, where countless other realities may exist, with values that preclude life. In the next chapter, we will explore how the idea of the multiverse has taken root in human culture, in literature, film, and art, where imagination reaches beyond science to touch the multiverse is not only a scientific hypothesis, it has long been a powerful motif in art, literature, and culture. Before physicists ever dared to speak of parallel worlds, storytellers were weaving them into myths and fictions. Today, the idea of the multiverse inspires novels, films, and visual arts, giving us not only entertainment, but also a mirror for our deepest hopes and fears. Even in the 19th century, writers speculated about parallel realities. H.G. Wells, in The Time Machine, did not describe multiple universes directly, but raised the question of how humanity might evolve under different conditions. Later, in the 20th century, science fiction exploded with visions of alternate worlds. Isaac Asimov, Ursula K. Le Guin, Philip K. Dick, and many others wrote of parallel histories, alternate timelines, and branching possibilities. In these stories, the multiverse is not just a scientific setting, it is a way to explore human destiny. What would have happened if a different choice had been made? What if history had turned another way? Such questions haunt us all, and literature allowed us to live through countless possible futures and pasts. Fiction made the multiverse intimate and personal, bringing it into the everyday lives of readers. Cinema embraced the idea as well. Films about parallel realities became not just entertainment, but philosophical experiments. The Matrix forced audiences to wonder, what if reality itself is an illusion? Christopher Nolan's Inception blurred the lines between dreams and universes. More recently, the Oscar-winning film Everything Everywhere All at Once turned the multiverse into a chaotic, emotional exploration of love, regret, and meaning. These works demonstrate how the multiverse can be a stage for Why is the multiverse so captivating in art? Perhaps because it reflects our most human concerns. We fear we have made the wrong choices, but the idea of parallel worlds comforts us. Somewhere, another version of us chose differently. We dream of second chances, and the multiverse offers endless ones. It is both a consolation and a challenge. If infinite possibilities exist, then who are we in the one we live? Interestingly, cultural visions of the multiverse often precede scientific theories. Writers anticipated the notion that every choice creates a new branch long before physicists like Hugh Everett proposed the many worlds interpretation. Science fiction becomes a laboratory of ideas, daring to imagine before equations confirm. And sometimes, scientists admit that they were inspired by novels and films when developing their theories. Philosophers see cultural depictions of the multiverse as reflections of our search for meaning. We are not satisfied with one reality. We long to imagine others, to better understand our own. Through stories of alternate worlds, we confront our desires, our regrets, our fears. In this way, literature and film perform the same role as science, expanding the horizons of thought. Let us pause for a rhetorical question. If every novel, every film creates a new world for us to enter, are we not already practicing a kind of multiverse travel? Each book opens a parallel reality shaped by the author's imagination, and each reader experiences it uniquely. Perhaps art is itself a multiverse, with every story a universe unto itself. The multiverse also appears in visual art and popular culture. Comic books, for instance, have long used the device of alternate realities. DC Comics and Marvel built sprawling multiverses where heroes meet their counterparts from parallel worlds. These stories entertain, but they also ask profound questions. What makes us who we are? If infinite versions exist, which choices define us and which are accidents of circumstance? Science fiction writers have often used the multiverse to address moral dilemmas. Philip K. Dick explored fractured realities to probe paranoia, identity, and truth. Ursula Le Guin used alternate worlds to examine culture and morality. By presenting worlds where different values or histories prevail, authors force us to reflect on our own. The multiverse becomes a stage for ethical inquiry. In contemporary culture, the multiverse has become almost a metaphor for modern life. In a digital world where we inhabit multiple online identities, where we switch between realities on our screens, the concept resonates deeply. Virtual reality, video games, and social networks all create parallel worlds we navigate daily. The scientific hypothesis becomes a cultural condition. Philosophically, the popularity of the multiverse in culture shows that it touches something primal. We are creatures of imagination. We cannot help but wonder what might have been, or what might still be. The multiverse gives form to these longings. Whether in science or art, it is the symbol of possibility itself. Thus, the multiverse in culture is not merely a plot device. It is a mirror of our souls, a way of exploring infinity within the finite span of human life. And perhaps it prepares us for the scientific discoveries to come. If physicists one day confirm the reality of multiple universes, we will not be surprised. We have been living with them in our stories all along. In the next chapter, we will turn to philosophy and religion to see how thinkers through the ages have wrestled with the idea of many worlds and what it means for humanity's place in creation. The question of many worlds has never belonged solely to science. It has always carried deep philosophical and religious implications. If multiple universes exist, then what does that mean for humanity? Are we unique, or just one variation among countless others? Such questions were asked long before modern physics, and they continue to challenge us today. In antiquity, philosophers already debated the idea. Leucippus and Democritus, the atomists, argued that if atoms are infinite, then so too must be the number of worlds. Epicurus expanded on this vision, suggesting that there are worlds like ours and others utterly different, some with life, others lifeless. For the Greeks, this was not science fiction, but a logical extension of infinity. Humanity ceased to be the center of everything. It became part of a vast multiplicity. The Middle Ages told a different story. In Christian Europe, the universe was understood as singular, created by God, and centered on Earth. The idea of other worlds was often branded heretical. Yet even then, some thinkers dared to push boundaries. Nicholas of Cusa imagined an infinite universe with Earth as just one among countless worlds. Giordano Bruno went further, proclaiming that the cosmos contained innumerable suns with their own planets, some perhaps inhabited. For this, he was condemned and Religions respond differently to the possibility of multiple worlds. Christianity, with its emphasis on the unique history of salvation, long resisted such ideas. Yet in modern times, theologians have begun to ask, if God is infinite, could he not create many worlds? Islam, too, speaks in its sacred texts of worlds in the plural, though interpretations vary. Hinduism and Buddhism, by contrast, have always embraced multiplicity. Their cosmologies describe universes that arise and perish in endless cycles. Philosophers of the modern era also grappled with the question. Blaise Pascal wrote of man lost in the infinite spaces of the cosmos. Immanuel Kant speculated on the existence of other worlds and their inhabitants. In the 19th and 20th centuries, the discovery of galaxies beyond the Milky Way gave new weight to these reflections. If our galaxy is just one among billions, then surely the idea of countless worlds is not mere speculation, but a natural conclusion. Today, philosophers continue the debate. Some see the multiverse as a scientific hypothesis. Others consider it a metaphysical concept. If infinite worlds exist, does everything possible occur somewhere? Some argue yes, while others caution that infinity does not guarantee all possibilities. The debate remains unresolved, and perhaps it always will. But this uncertainty is part of what makes the question so compelling. Here we must ask, does the idea of many worlds diminish our importance? Or does it, paradoxically, make our existence more meaningful? If there are countless versions of humanity, our particular lives may seem less unique. Yet from another perspective, meaning is not diluted, but intensified. For even in infinity, this moment, this experience, is ours alone. Different traditions find different values in the concept. For religious thinkers, multiple worlds may testify to the greatness of the Creator. For philosophers, they are an invitation to reflect on freedom and necessity. For scientists, they are a challenge to uncover the hidden laws of reality. Thus, the multiverse becomes a bridge between disciplines, uniting faith, reason, and inquiry in a shared pursuit of truth. The stories of those who dared to think in terms of many worlds are often dramatic. Bruno's death at the stake is a reminder of the dangers of radical thought. Nicholas of Cusa was ridiculed in his time, but celebrated later as a visionary. Today's thinkers face not persecution, but skepticism, as they wrestle with reconciling multiverse theories with philosophical traditions. Each generation confronts the same challenge, to imagine beyond the visible, to expand the boundaries of human thought. Thus, philosophical and religious reflections on many worlds accompany us across history. They remind us that the desire to go beyond the known is part of our very nature. We seek not only to survive, but to understand, not only to measure, but to find meaning. The multiverse, whether real or imagined, speaks to this eternal quest. And in the next chapter, we will turn from philosophy to evidence, asking what signs science might find to support the existence of other universes. Scientific hypotheses remain speculation until they encounter evidence. The multiverse sounds majestic, but can it be tested? How could we ever confirm the existence of other universes if, by definition, they are beyond our direct observation? These questions have occupied physicists and philosophers alike for decades. One possible path lies in the cosmic microwave background, the faint radiation left over from the Big Bang. It is the oldest light we can see, filling space uniformly. Some theorists propose that if our universe ever collided with another, it might have left traces, subtle rings or anomalies in this background. Indeed, a few studies have claimed hints of such patterns, though the interpretations remain controversial. The search continues, with each new map of the sky offering a chance for discovery. Another avenue is gravitational waves. These ripples in space-time, predicted by Einstein and first detected in 2015, carry information about cataclysmic cosmic events. Some physicists believe they might also preserve signatures of processes from the very birth of the cosmos. If eternal inflation is real, collisions of bubble universes could generate distinctive gravitational wave patterns. Detecting them would be an extraordinary breakthrough, transforming philosophy into empirical science. Particle physics offers another hope. Experiments at accelerators like the Large Hadron Collider probe the deepest structures of matter. Certain outcomes, such as the discovery of evidence for extra dimensions or unexpected fields, could lend support to theories where the multiverse arises naturally. While such results remain speculative, they demonstrate how even laboratory experiments on Earth might connect to the largest possible questions about reality. But here arises a philosophical dilemma. Can the existence of other universes ever truly be proven? If they are forever inaccessible, is the multiverse outside the scope of science? Some argue yes, pointing out that a hypothesis must be falsifiable to be scientific. Others reply that indirect evidence can be enough. If the multiverse provides the best explanation for observed phenomena, then it earns its place within science, even if direct observation is impossible. History offers examples of ideas once thought untestable that eventually gained evidence. Atoms were debated for centuries before experiments confirmed them. Black holes were considered speculative until observations revealed them. Gravitational waves were predicted for 100 years before they were detected. Perhaps the multiverse, too, awaits its moment of confirmation once our instruments become sensitive enough. The human stories here are compelling. Teams of scientists devote years to searching for subtle signals in cosmic radiation, often facing skepticism from colleagues. Some are convinced the evidence will come. Others caution that it may remain forever elusive. Yet all agree that the pursuit itself expands our understanding and drives innovation. Even if the multiverse remains unproven, the search refines our science. Rhetorical questions inevitably arise. What would it mean if one day we did find evidence of other universes? Would our daily lives change? Would humanity suddenly feel smaller or larger, knowing we are part of an infinite mosaic. Perhaps the greatest change would be internal. Even without proof, contemplating the multiverse already stretches our imagination. Evidence would not only confirm theories, but also transform our worldview, affirming that reality is far stranger and vaster than we dreamed. Philosophers of science remind us that the act of searching is itself meaningful. To stand on the edge of knowledge and peer beyond is part of what defines humanity. The multiverse may or may not reveal itself, but in seeking it we affirm our deepest drive: to know, to explore, to wonder. The boundary of science is not a wall, but a horizon, one that always recedes as we approach. Thus, the search for evidence of the multiverse is more than a technical challenge. It is a journey at the limits of knowledge, whether through cosmic radiation, gravitational waves, or particle experiments. Each attempt deepens our understanding. And even if confirmation never comes, the very process enriches science and philosophy alike. In the next chapter, we will turn to the mystery of time and eternity, and how the multiverse reshapes our understanding of them. Time has always been one of the greatest mysteries of human thought. We sense its flow, measure it with clocks, and yet struggle to define it. Is time an objective reality, or only a perception? Does it have a beginning and an end, or is it eternal? The concept of the multiverse pushes these questions into new dimensions, challenging us to rethink what we mean by past, present, and future. And modern physics tells us that time is inseparable from space, woven into the fabric of space-time. Einstein showed that time is relative. It slows near strong gravity and for objects moving at high speeds. In the vicinity of black holes, time itself stretches differently than on Earth. Already, our everyday intuition falters. But what if in other universes, time works in completely different ways? What if there are worlds where time loops in cycles, or others where it does not exist at all? The multiverse invites us to imagine such possibilities. If there are countless universes, why should they all share the same temporal structure as ours? Perhaps in some, time flows faster or slower, or not at all. Some may contain multiple timelines, branching and merging like rivers. Others may have no distinction between past and future. In contemplating these variations, we confront the limits of our imagination. Philosophers have long wrestled with the enigma of time. St. Augustine admitted, "What then is time? If no one asks me, I know. If I wish to explain it, I know not." Immanuel Kant argued that time is not a property of reality itself, but a framework of human perception. For Einstein, time was elastic, molded by matter and energy. The multiverse adds yet another perspective. Time may not be singular but plural. It may exist in many forms, depending on the universe. Eternity also takes on a new meaning. In traditional thought, eternity often meant timelessness, an unchanging state beyond time. But in a multiverse, eternity can be dynamic. If universes are constantly born through eternal inflation, then creation never ceases. Eternity becomes not a static stillness, but an endless process of becoming. Instead of a single beginning in the Big Bang, there are countless beginnings, endlessly renewed. Rhetorical questions emerge. If there are infinite timelines, what does now truly mean? Is our present just one bead on an infinite string of moments? Or is it something more? Does our experience gain or lose value when placed against eternity? Perhaps its value lies precisely in its fragility. We cannot hold on to time. We can only live it. And that fleeting quality makes each moment irreplaceable. Physicists like André Linde have described eternal inflation as a process without end. To him, this was not only a mathematical conclusion, but a philosophical one. Time itself becomes eternal, with universes sprouting endlessly like blossoms in an infinite garden. Other physicists propose cyclic models, where universes collapse and are reborn. In such visions, time does not stretch infinitely in one direction, but circles back upon itself. Each universe has its life, death, and rebirth in a cosmic cycle. Human culture has long imagined cyclical time. In Hinduism and Buddhism, vast cycles of creation and destruction repeat eternally. The ancient Stoics also believed in recurring cycles of the cosmos. Modern cosmology, in its own way, has revived these ideas, showing that our universe might not be a one-time event, but part of a larger rhythm. What does this mean for human existence? If time is infinite, are our lives insignificant? Or does the opposite follow? That in infinity, each life is infinitely valuable. Philosophers suggest that meaning does not vanish in eternity. It becomes even more precious. Our brief existence shines against the backdrop of infinity like a candle in the dark. Small, yes, but luminous. Stories of scientists and thinkers illustrate how the idea of time in the multiverse reshapes worldviews. Einstein once comforted the family of a friend, saying, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." Hugh Everett, with his many worlds interpretation, implied that all possible futures are realized somewhere, so in some sense, nothing is ever lost. These reflections blur the line between science and consolation, between equal. Let us consider another rhetorical question. If all possible versions of time exist somewhere in the multiverse, then which one do we call real? The answer may be all of them, and yet none exclusively. Reality itself may be broader than any single timeline. We inhabit one thread of the cosmic tapestry, but the fabric extends beyond imagination. Thus, the multiverse transforms our understanding of time and eternity. Time is no longer one-dimensional, no longer confined to our experience. Eternity is no longer static but dynamic, the endless unfolding of universes. And our lives, though brief, gain meaning in this vastness. For in the ocean of infinity, the fact that we are here, now, conscious and questioning, is nothing short of extraordinary. In the next chapter, we will turn to the human dimension once more. The question of free will, responsibility, and meaning in a universe, or multiverse, where all possibilities may be realized. Free will has always been one of the central debates in philosophy. Are we truly free to choose, or are our decisions predetermined by laws of nature, genetics, or fate? The concept of the multiverse complicates this debate further. If every possible choice is realized in some universe, then what does freedom mean? Does responsibility vanish, or does it take on a new dimension? At first glance, the many worlds idea seems to undermine responsibility. If in one universe I act kindly and in another cruelly, does either choice matter? Am I not simply one actor playing infinite roles in infinite scripts? But when we look deeper, we see that meaning lies precisely in consciousness. Yes, there may be other versions of me elsewhere, but I only live this life, this thread of the tapestry. The choices I make here are mine, and their weight cannot be transferred to another branch. Philosophers have long grappled with the paradox of freedom and necessity. The Stoics believed everything was predetermined by fate, but that true freedom lay in accepting it with dignity. Existentialists like Jean-Paul Sartre, by contrast, insisted that man is condemned to be free. No matter the circumstances, he must choose, and in choosing, he defines himself. The multiverse brings a new twist. All choices may be realized somewhere, but responsibility belongs to the one we experience. The story of Hugh Everett and his many worlds interpretation illustrates this tension. His mathematics implied that every quantum event spawns new realities. Literature quickly adapted the idea, filling shelves with stories of alternate selves meeting or diverging. Almost always, the lesson is the same. What matters is not the infinite array of other lives, but the authenticity of the one we live. To act as if our choices do not matter because other outcomes exist elsewhere is to betray the unique value of... Let us pause for a rhetorical question. If every possible decision is made somewhere, does morality collapse? The answer, many argue, is no. Morality is not about abstract possibilities, but about the lived reality of conscious beings. I am not responsible for what my double in another universe does. I am responsible for what I do here. My decisions shape the world I inhabit. This responsibility cannot be outsourced to infinity. The multiverse also redefines our understanding of destiny. If all possibilities are realized, then somewhere, every dream comes true. But this does not mean effort is meaningless. For us, only this branch matters. Our actions here define the story we experience. In a way, the multiverse magnifies responsibility rather than diminishing it. Against the backdrop of infinite possibilities, our particular thread gains even greater weight. Writers and thinkers have often explored this. Dostoevsky portrayed freedom as both a gift and a burden. To be free is to risk guilt, failure, even destruction. Yet it is also to be truly human. In the context of the multiverse, this burden deepens. Knowing that other versions of us exist does not lessen our responsibility. It sharpens it. We cannot live their lives. We must live ours with courage and honesty. Here, another rhetorical question arises. What does it mean to love, to create, to hope, if somewhere else we fail to do so? Perhaps it means even more. For love chosen here, in this moment, has value precisely because it could have been otherwise. Creativity matters because it springs from the finite circumstances of this universe. Hope matters because we carry it despite uncertainty. Each act becomes a declaration of meaning in the face of infinity. Philosophically, one might say the multiverse elevates free will by showing its limits. We cannot control what happens in other universes, only in this one. That boundary clarifies our responsibility. Our freedom lies not in omnipotence across all worlds, but in authenticity within our own. In this sense, the multiverse reminds us that freedom is always concrete, never abstract. The human stories resonate here. Everett himself struggled with recognition, leaving academia disillusioned. Yet his idea outlived him, inspiring generations. Sartre insisted that every choice shapes identity. Modern physicists debate whether free will is compatible with quantum determinism. Each perspective adds to the tapestry, but the thread we live is ours alone. Thus, the multiverse does not abolish freedom or responsibility. It reframes them. Freedom is the conscious act of inhabiting one branch among countless others. Responsibility is the weight of our actions in this world, not in others. Meaning is not diluted by infinity, but intensified by it. Our choices shine brighter because they stand against the endless backdrop of what could have been. In the final chapter, we will bring our journey to a close. We will look at the future of science, philosophy, and humanity in the face of the infinite, and ask, what role do we play in the vast ocean of worlds, and how can we live with inspiration in the knowledge of such immensity? Our journey through the multiverse has reached its conclusion. We have traveled from myths of ancient peoples to the equations of modern physics, from philosophical speculations to cultural creations, from the mysteries of quantum mechanics to the vast landscapes of cosmology. Along the way, we have encountered thinkers who risked ridicule, persecution, even death for daring to imagine other worlds. And now, at the end of this path, we must ask, what does the multiverse mean for us? First and foremost, the multiverse expands our imagination. It shows us that reality may be far richer and stranger than we suppose. If our world is but one of countless others, then our horizons extend without limit. We are invited to think not in terms of a single universe, but of infinite possibility. This shift in perspective is itself transformative. Once we see beyond one reality, we cannot go back to thinking narrowly. Philosophically, the multiverse confronts us with profound questions. Are we unique or ordinary? Does life gain or lose meaning in infinity? The answers vary, but the questions themselves elevate us. For to ask such questions is to transcend mere survival. It is to enter the realm of wisdom, to seek meaning in the face of immensity. In this way, the multiverse is not just a theory of physics, but a mirror for the human spirit. The stories of those who pursued these ideas inspire us. Giordano Bruno, who spoke of infinite worlds and paid with his life. Hugh Everett, who dared to say that every possibility is real, though few believed him. Andre Linde, who followed mathematics to the conclusion of eternal inflation, even when it seemed absurd. These are stories of courage, imagination, and resilience. They remind us that human progress depends on dreamers as much as on skeptics. Let us pause with a rhetorical question. Why should we care about universes we will never see? Perhaps because they remind us that even within our small lives, possibility abounds. We may not travel to other worlds, but we can choose how to live in this one. The multiverse is a metaphor for the infinite choices, chances, and futures within our reach. It challenges us to live fully, authentically, meaningfully. Culturally, the multiverse has already become part of our imagination. From novels to films, it allows us to explore alternative lives, histories, and identities. It reflects our deepest longings for second chances, for different outcomes, for hidden depths of reality. Art prepares us for what science may one day confirm. And even if confirmation never comes, the stories enrich us, showing that our imagination itself is a kind of multiverse. Science will continue the search. Perhaps one day, evidence will emerge in the cosmic background radiation, in gravitational waves, or in the structure of fundamental physics. Or perhaps the multiverse will remain forever beyond empirical reach. Either way, the idea has already changed science by stretching its boundaries. It has already changed us by expanding our minds. So what role do we play in all of this? We are not the center of the cosmos, but we are participants in its unfolding mystery. Out of all possible universes, we find ourselves in one that gave rise to life and consciousness. This is extraordinary. The universe is vast, dark, and indifferent, and yet here we are, beings who can love, create, and wonder. That fact alone is a miracle worth celebrating. In the face of infinity, our lives may seem small, but smallness does not mean insignificance. A candle is small, yet it can light the darkness. Our brief existence shines all the brighter against eternity. Each act of kindness, each creative work, each question asked is a spark in the cosmic night. The multiverse reminds us not of our futility, but of our capacity to bring meaning into an immeasurable expanse. Thus, we end our journey not with answers, but with inspiration. The multiverse is a challenge to our science and our philosophy, but also to our humanity. It invites us to imagine boldly, to act responsibly, to live deeply. It tells us that reality is greater than we can grasp, yet not beyond our wonder. And so, my dear listeners, let us leave with this thought. In the ocean of infinite worlds, this world is ours. This life is ours. This moment is ours. Let us cherish it, honor it, and live it fully. For in the vastness of the multiverse, nothing is more miraculous than the fact that we are here, together, asking questions and seeking meaning. And as long as we do so, we are part of the greatest adventure of all, the adventure of being human in an infinite cosmos.